Okay, good. So we looked at the exponential function with a base greater than 1. So let me just refresh your memory. We graphed, so always it passes, if it does not shift left and right, it's a pure exponential function like 2 to the x. It always passes when x is 0. 2 raised to 0 is 1, right?
Yeah.
Remember with the 2, okay. So the graph will always look like this if the base is greater than 1. And since I'm here, I'm going to give you 2 more examples. E to the x. Question. What is E? E is a number that pops up in real life situations, and you will see applications of this later. So it's so important that it has its own key right here in the division symbol. So if you go to second and the division, you will see E, and if you press enter, you will see it's 2.71828. It's Euler's number, mathematician that invented or looked at a lot of different things. And he came up with this number, and he showed how important this number is in real life situations, real life models. And that's why they call this number E, from his name. Euler's number. Now, just to not connected to what we're doing right now. So you remember that there is something called pi. Okay. Now the Greeks came up with this letter. It's basically P, the Latin P, but that's the Greek P. Okay. So, but anyway, so this is pi, right? But this is P, and that's their P. Now, their pi. What I was going to say is, how did they come up with this, and why did they give such a name or a letter to 3.14, right? So it's so important again that if you go here to the caret, second and caret, you will see the pi, and when you press enter, you will see 3.14, blah, blah, blah. Okay? So how did they come up with this, and why did they have to name it? Here's why. So imagine that this is a circle. I know it's not, but just say, yes, it is. Okay. So they measured, that was before, I don't know. I have to look it up. Many years ago. So when they were first experimenting with anything, okay, so they said, okay, let's measure the circumference. So somehow they measured the circumference of the circle, and they measured the diameter of the circle. They divided the circumference by the diameter, and they got this number. Then they looked at another circle, this circle, much smaller. They measured somehow the circumference, and also they measured the diameter. For this circle, the circumference divided by the diameter is this number. For any circle, the circumference divided by the diameter is this number. So then they said this must be important, so let's give it a name. So they did. Okay? Again, not related to what we're doing right now. That's not related. But that's how this mathematician did the same thing. Showed that this number appears so frequently in real life situation that it bears its name, sort of, just the first letter. Okay? So now we know that E is a number greater than 1. So if I want to graph this, this is how will I graph it? A little bit closer to the y-axis. We're going to graph all these in a minute with a graphing calculator. Okay? So this function f of x equals e to the x, it's called the natural. I will show it to you in the calculator in a minute. Exponential function. Natural, as I said, because it appears in real life models frequently. Here's another one. 10 to the x. This is does not appear in real life as much as the e to the x does. And I'll show you an example in a minute. But it's important, and it's called the common exponential function. The higher the base, the closer the exponential function will be to the y-axis. So then if I want to graph this, I will graph it like this. Closer. So this in red is 10 to the x. So let's look at a graphing calculator. So here's 10 to the x in blue, right here, next to 7. And here is e to the x in blue, next to 4. So let's go to y equals at the top. I like the software. It's not as good as it looks. There are certain things that it cannot do. But I really like the fact that I see 3 colors. So now I will graph, together with you two, caret x. The next one, just press on second and 10 to the x and put x. Second and 10 to the x, left from 7. And put x. Oh, x is always this, where all these letters are.
Okay.
That's the x. And then enter again. And now let's look at the last one. Allow me to put them in the same order, because I want you to see that 2 is the furthest away from the y-axis. E will be closer, and 10 will be the closest. So let's delete this one. I'm sorry, forgive me. So clear this and put it in the next one. So that's where I want to put 10 to the x so we can see. And then go back to y2 and just put second and e to the x. I want them in ascending order. So 2 is the smallest, e is the next, 2.71, and 10 is the last one, because I want you to see now how the last one is the closest. I already have them here. I really didn't want you to see them just yet, but they're already here. So now let's go to zoom, and let's choose 6, the standard viewing window. Careful, here's the first one, 2 to the x.